Hello, everyone. Welcome. My name is Pavol, and I'd like to tell you about the smart correlation feature in Midpoint. Today, we'll start with a brief description of the correlation and its features in Midpoint. Then a short demo will be presented. Afterward, we'll discuss advanced experimental features, and we'll finish with a short conclusion and describing the next steps. So, what's the correlation? Generally speaking, it means matching identity data coming from the external world against a set of known identities present in the Midpoint repository. It is needed to establish links between identities so that we know, for example, that a particular record in HR system for John Smith is about the same John Smith as, for example, this record in Active Directory or Google Docs, and even that this Ian Smith here, even with a slightly different name and a mistake in the date of birth, is also the same person. Well, since the early days of Midpoint, the resource synchronization has been the primary use of correlation. But recently in 4.8, the identity recovery feature, also known as Find My Username, was added, and it uses the very same mechanism of correlation. And we are also thinking of using the correlation also for registration and self-registration processes in the future. Now, why is correlation often a very tough problem? In an ideal world, the identity data would contain at least one identifier that could be used to match the records. Unfortunately, in real life, this is often not so. First of all, the privacy laws restrict the use of national-wide IDs like social security numbers or birth numbers. Then these identifiers can be missing for some persons, typically for foreigners. And sometimes even those numbers are non-unique because of errors made perhaps decades ago. Other quasi-identifiers like email addresses or phone numbers are often quite weak. They can change over time, have multiple or no values for a given person, and so on. Then, even if we have some more or less identifiers, there is a problem of their representations. All the mentioned attributes usually have a variety of those, differing in dashes, slashes, phone number formats. For names, there are diacritical marks, special characters, or the problem of multiple names per person. And as far as addresses are concerned, all we know that they are practically incomparable if stored in their free form. And finally, there are issues of data quality. Yes, it may vary because of typically of data entry errors, omissions, or sometimes even because of deliberate falsification. Overall, the correlation is a complex problem, and each identity management system has to deal with it somehow. Now let's get back to Midpoint. And in recent years, we tried to provide a solution. It's covered under the term smart correlation. Probably the most important feature is what we called composable correlation rules. What was that? Instead of insisting on a single statement like, well, the correlation will be done by the national ID, Midpoint now allows you to specify a set of such statements, each with its own confidence value. These rules support not only the exact matching, as it was before, but also approximate matching using Levenshtein distance and trigram similarity. Then, if the match cannot be determined with certainty, now Midpoint can open a case to be resolved later by a human operator, just like approvals and manual resources are. And there are also two experimental features, custom indexing and multiple sources of truth, that we will cover soon. Let's have a look at these features in more detail now. For the sake of our explanation, let's assume we have 4 pieces of personal data that we would like to use for correlation: given name, family name, date of birth, and the national ID. And the first rule, let's say, maybe like this. If the family name, date of birth, and the national ID all match, we declare we found the identity with certainty. The assumption here is that the differences in the given name are not relevant in this case in our deployment. Confidence value of 1.0 or 100% denotes the full certainty of the match, that we consider this the truth. The second rule may state that if the given and family names and the date of birth all match, we consider this identity for human resolution. So we don't say that this is the match, but we say, please have a look at this if it is a match or not. This rule is mainly to cover cases where the national ID is missing or wrong. And to make the rule more robust, we allow approximate match for the names. Let's say we will consider such a match with up to 40% certainty, depending on the closeness of the names. And finally, our third sample rule: if only the national ID matches, then the identity is again considered for human resolution, regardless of the other data. This may cover cases such as alternative family names, maiden names, and other types of mistakes or issues. Again, all of this is fully configurable. These 3 sample rules are just an illustration for the upcoming demo. Here we can see how this configuration can be entered into Midpoint via the resource wizard. We specify the rules along with their weights and optionally with relations among them, and then the details of individual rules are at the separate screen. For example, in the second rule, the given name is compared using the Levenstein distance that should be at most 1, meaning just 1 character difference is allowed for the match to be considered. Let's now present a short demo. Here we run a Midpoint for a fictitious university with 3 campuses, each with its own independent student information system. We have already imported 10,000 students from the campus 1, and now we are connecting the systems from campuses 2 and 3. We use fully random names, kindly provided by the fakenamegenerator.com. So let me switch here. So here, okay. Here are our users from campus 1 already imported. And here are our resources. Let's open the campus 2 system accounts. And here are sample 10 accounts. So let's have a look. This is Anthony Martinez that has the data exactly as they are in campus 1 in our demo. If we import the account, it gets immediately linked as quite natural. It gets immediately linked to the existing user without any questions because, well, there is a full match. Then let's open the second account. It belongs to Brandon Banks that differs from the data in Midpoint in the given name. Bran here on campus 2 and Brandon is on campus 1, therefore also in Midpoint. This one also gets imported automatically because our rule number 1, as you remember, says that the given name equality is not required if other properties are the same. Now it gets more interesting because this is Thomas Betts that has a mistake in the national ID number here. The correct number ends with 5, and here we see a mistake of 6, a kind of typo when entering the data. After importing this account, we see that the synchronization situation is not linked, but disputed. And because we configured the system to open a correlation case for this kind of situation, there is one, really. So we see that, yes, here is a correlation case. We can open it. And we see that there is one work item. It is assigned to the administrator. This can be configured. And here can be a deadline. There is none, but this can be configured as well. So now let's open the work item. And let's have a look. We see here that this is the resource. This is the account. We want to correlate this one. We can click on it to see the details, Thomas Betts and so on. And this account corresponds to the following user properties. They were created by inbound mappings, particularly those that are enabled for the use of correlation. By default, all inbound mappings that are needed for correlation are evaluated here. Those are those 4, as we know that those are items in our correlation rules. Plus, you can also specify explicitly some additional properties to be displayed on this screen. So I did that for the locality, because it will be it isn't compared automatically, but it provides additional information for the human operator to decide. And we see that we have 3 potential matches here. This one that the pre is here because of the rule number 3. There is an exact match of the national ID. The wrong national ID of Thomas Betts corresponds to the correct one of Wanda the pre, and obviously all other properties do not match. Then the other 2 matches are here because of the rule 2, that is exact or approximate match of names plus exact match of the date of birth. Yes, we see that Thomas Betts' date is here because of these 3 properties, and the Thomas Betts with 1 T is here because of exact match of given name and date of birth and approximate match of the family name. There is 1 character difference. The data are colored depending on the match. Green means obviously full match, red is no match, and the yellow is partial match, according to the correlation rules specified. The confidence values are displayed here. If we would like more information, we can find it by hovering the cursor over the eye icon here. For example, here we see that the rule about the names and date, second rule, was applied, and that the family name was matched with 50% confidence because of the Levenstein distance of 1, and this results in 20% confidence overall. Even more details can be obtained by inspecting the account here or individual users here. Yes, we can click, inspect, and go back. Okay. Now we can make a choice. We can say that this account belongs either to one of the candidate owners by clicking here, here, or here, or to none of them by clicking here. This will mean creating a new record. Let us say we conclude that this is indeed a mistake in the national ID, and the owner of this account is this Thomas Betts. Okay, so we click correlate here. and we are done. Now, let's get back here and let's briefly describe some of the advanced features of the correlation rules. Sometimes we may have overlapping rules. For example, if both given and family names match, let's take the confidence of 20%, because that can be quite a coincidence. If the family name matches, be it even only 10%, naturally we would expect any candidate with both names matching to have the confidence of 20. In fact, it would be 30, because both rules apply here, this and this. So to provide more natural and intuitive results, we may say that the rule number 9 should be evaluated only if the rule number 8 does not apply. Okay, sometimes we may want to spare the computational resources and stop the correlation process after it's clear that we have found the correct owner. In our example, we can say that after the rule number 1 finds the match, we will not consider any remaining rules. This can be done by grouping into tiers. Now, and finally, we can customize what is shown to the operator. By default, all matches with confidence greater than 0 but less than 100% are shown, and the one with 100%, if any, is taken automatically. But these boundaries can be configured, changed, so that, for example, we can show matches with confidences between, let's say, 20 and 90%, and take the match that's 90 or higher if there is exactly one automatically. Now, let's describe two experimental features. The first one is called custom indexing. The idea is to extend standard matching options by the pre-processing step. For example, keeping only a prefix of the value, or using a custom polystring, or even custom Groovy-based normalization before the matching. The computed data are maintained automatically in the user object, and this normalization is similar to the use of mappings, with the advantage of being simpler, maybe a bit faster, and hidden, so that it does not pollute audit logs, preview screens, and so on with this kind of technical information. And it can be defined like this for the polystring normalization, followed by taking a prefix, or like this, using custom Groovy script to derive the value, the normalized value to be matched. This is, well, I would say quite a minor feature, but the major one is the ability to maintain multiple sources of truth, so to say. As we said at the beginning, due to various reasons, a piece of information like the name, title, or date of birth, and similar, may have different values in individual sources. Until the data are fixed at the sources, Midpoint must cope with those differences somehow. And this is where multi-source feature steps in. It allows you to do two things. First, to write rules that will determine the authoritative source of data. And second, it will take those alternative representations that are not put into the official data, so it will take them also into account when doing the correlation. Let's illustrate that on a simple scenario involving HR and student information system. Let's say we have a mapping from first name in the SIS to user's given name, as well as a mapping from forna, a SEP attribute, again to the user's given name. If we have a user with both names the same, let's say John here and John there, everything works fine. But if there is a difference, like Ian in SIS and John in HR, reconciliation would crash with an error stating that it's not possible to put two values, John and Ian, into a single valued given name user property. I'm sure that you know this situation very, very well. However, after you mark the given name property here as multi-source, A rather interesting mechanism gets into play transparently on the background. With no change in the mappings, the values would be stored not into the user's given name directly, but to the hidden identities container instead. You then just have to write an expression that gets the data about identities of the user and says which one is to be taken as authoritative either for all the data or just for particular property. And this value from this identity will get automatically transferred into the target property, the given name in this case. And moreover, when correlating, the data from all the identities are taken into account. That means not only the official given name. Let's show that in a short demo. Again, so let's assume we have a user called Yolanda Becker here on campus 2. I think this is she. Yes, Yolanda Becker. And but Becker is the maiden name. The lady is now called Yolanda Johnson. The campus 1 is more up to date. So if we look her, Johnson, okay. Yes, she came from campus 1. Oh, I'm sorry. And the name is, yes, Yolanda Johnson. Okay. In campus, as I said, in campus 2, her name is still Becker. After we import her, so we just click here. We got into a disputed situation because the differences between the names cannot be resolved automatically. So we will just do the correlation here. So cases, all work items. And so we see that this Yolanda Becker is probably this Yolanda Johnson, but we are not, midpoint is not sure. We just confirm, okay, this is her. Okay, so far so good. Now, how will midpoint know which name, Johnson or Becker, to use for the user? As I said before, we have to configure that. So for this demo, we created a very simple data selection algorithm. It says that the data from campus 1 will always take precedence over the data from campus 2 and 3. It's just for the demo. You could and should, in fact, write something much more elaborate in your deployment, taking, for example, the origin of data or the timestamp of last change or something like that into account when selecting the most correct version. So we see that the user here, let's return to the user. The user gets the Johnson value as the official name, even if there are two sources with campus 1 and campus 2. Okay, but let's continue. Let's say that campus 3, that she is so diligent student that she studies also on campus 3, and unfortunately on campus 3 she still has the old name, and let's assume further the national ID is missing here. I would say quite bad situation, because we have nothing to correlate with the user, because national ID is not here, and the name here is wrong. It's old. Becker versus Johnson. Fortunately, even with this situation, when importing, the candidate owner is found, thanks to the matching of the alternative name of Becker, because it is stored along with the official name within the user record. Let's open the work item, and we see that really here is the a record to be matched. We see no national ID, old name. And here is the user record. The primary or official name is Johnson, but there is also an alternative of Becker. And this is why this match was found. The yellow color means that there is a match on the secondary, I would say, value. And the secondary value or values are shown in parentheses. And also please note that the blue color here means no matching could be done because the value is present here, but not present in the object being matched. So in this case, we can safely correlate this account to this user. Okay. Coming to a conclusion, we can say that the current implementation of the correlation provides both powerful and flexible means of the definition of rules. It provides fuzzy matching via the use of Levenstein distance and trigram similarity metrics. And there are also two interesting experimental features, custom indexing and properties with multiple sources. So we would like to encourage you to try this, including those experimental features, and let us know about your experiences, requirements, and other ideas. Then we can improve the smart correlation feature based on your feedback. I'd like also to invite you to next webinars. First one is securing midpoint deployments on April the 4th, then preparing for NIS2 directive on April the 18th, and then introduction to flexible authentication in May, with many more coming after that. And thank you very much for your attention.